So, today I will present the seventh research paper analysis. So the title of the paper that I analyze is Context-Based Codesmol Prioritizations for Prefactoring. This paper has been accepted to 2016 IEEE International Conference on Program Comprehensions. The ICPC, it was named IWPC, is the principal venue for works in the area for program comprehension, and this paper has been published last year. So in terms of how to determine the venue quality, the ICPC is one of the reputable venues, is listed as one of the top software engineering conferences and ranked C under the computer science conferences. And this paper has three paper citation counts. So as far as the problem statement of the work, the existing smell detectors are often unsuitable for developers who have a specific context. Why is that? Because these detectors do not consider their current context and output the results that are mixed with both smells and that are not related to such contexts. Consequently, the developers must spend a considerable amount of time identifying the relevant smells. So the author of this paper, the authors of this papers propose a technique to prioritize the bad smell using developer context to provide developers with a list of prioritized bad code smells related to their current context for prefactoring phase. So the basic idea of this paper is to propose a technique for prioritizing code smell detections resulted by considerations of the developer's current context. This technique actually is useful for planning how to prefactor the source code before implementing sets of issues in an issues tracking system. So this diagram shows the overview of the proposed technique. So the authors suggest to use the impact analysis to obtain a list of modules that are likely to be the targeted modules of each change descriptions. And they are using the code smell detection technique to generate a list of code smell by application of an existing code smell detectors with the source code of the focused projects. And lastly, the context relevance index or scoring. So for each code smell in the list, they calculate the CRI based on the relevance of the prior result of the impact analysis. So at the end, they output the prioritized list of code smell ordered by the CRI value. So the paper seeks to answer the following research questions. Which code smell granularity provide a better ranking? Is it the coarse grained or class level or defining grained or the method level? Does the accuracy of the impact analysis affect the quality of the ranking? And does context-based smell prioritization provide more relevant results than the severity-based smell prioritization? So to address these research questions, authors conduct an empirical study to validate their approach. So in the experimental implementation, the author implemented a tool for use with the proposed technique to trigger a code smell detector to generate a list of smells and to calculate the CRI of each smell. And during this phase, the infusion tool is used for smell detections. In the data collection phase, the authors analyzed 4 open source projects, and the data set include the list of summary and description, the list of executed method, and the goal set method of each issues during the analyzed period. In the data analysis phase, the authors use normalized discounted cumulative gain to evaluate the result of their approaches. So the following is the result for the proposed approach. So for the first research question, solving the study showed that solving code small at the class level or the course grain would contribute more to issue implementations than solving the code small at the fine-grained level. For the second questions, yes, the accuracy of the impact analysis tend to affect the equality of the ranking. And lastly, for the third research questions, the study showed that the context-based small prioritization provide more relevant results than the severity-based small prioritizations. So for the future work I would suggest to conduct case studies to confirm the relevant code smells are useful to developers, and considering other factors that might affect the developer's decision related to fixing a smell, such as the severity of smells, the effort needed to fix the smells, and the importance of the issues. And lastly, include more projects to evaluate the proposed technique instead of just restricted to just for open source projects. That's all about the seventh paper analysis, and thank you.